Hello friends, this is Eli with Mystic Circuits. Today I have a video on how to build the 0HP modules. This time we're dealing with the Vactrol based modules. I'm combining them both into one video because they're essentially the same module with the difference of only one part. So we'll be building the Vactrol VCA, and at the point where it differs from building the low pass gate, I'll let you know. This is probably the second easiest module to build, with the caveat that the VCA has a step where you have to calibrate things. Keep in mind that Vactrols are all different. They all have slightly different characteristics, so they're all going to sound a little bit different. And yours might not sound exactly like mine, but I'm going to try and get it as close as we possibly can. So this is the kit that you start out with. We're going to open things up and just go over what you should find inside. Just to make sure that everything's there, because I stuff it all by hand, and sometimes I make mistakes, so we check inside to make sure. Sometimes these resistors, the tape will get stuck against the side of the bag. So let's see what we've got here. We've got our wonderful glasses. We don't want to wear these while we're soldering. It'll make things much more complicated. So put those to the side for now. We've got our 4 audio jacks, which are used to patch signals in and out of the circuit. We've got our circuit board, which we obviously need. There's that. We've got the beautiful acrylic backing with the Mystic Circuits logo emblazoned upon it, so we can set that to the side. We need 2 sets of resistors. One is a single resistor marked 10K, and then we have this trio of resistors marked 1K. Those are both very important to have. We have this, what's called a trimmer resistor. It has a little brass piece on the top that lets you adjust the resistance with a lot of accuracy, fine detail. Put that to the side as well. You'll have this silver blob, which has the Vactrol inside, as well as an LED. And the plastic standoffs, you should have 4 of them. We won't need them till later. If you got the low pass gate kit, instead of the trimmer resistor, this guy, this blue box with the brass knob at the top, you will have a small capacitor. That's only for the low pass gate again, so if you're building the VCA, don't worry about finding that. Alright, so let's start out with the 10K resistor. The thing about the 10K is that it's not labeled correctly on the board, so be very careful to put this in the right spot. We can just pull all of that tape and paper off and everything. And then we'll look over here. If you watched the other videos, you might notice this theme here. The resistors, these guys, this is what a resistor looks like. I bent the leg over so that it'll fit in these holes. You'll notice here that we have a circle with a little line connecting 2 holes here. The line indicates which 2 holes the resistor goes through. The circle usually indicates which side the body is on, the body being this sort of blob with the colorful stripes on it. It's not important which way the body goes. Just go ahead and make sure that the resistor lines up with between the holes that the line is connecting. So the line basically indicates that you're not doing something crazy like having your resistor, go all the way across the board like this or something. Right, because if that line wasn't there, you'd just have to guess. So the resistor goes in between the 2 lines. Alright, we've got that guy in there. Now let's warm up our iron. Got some tape stuck on me. We have our solder, also very important. And we're going to tin the tip. How you do this is you just sort of wait for your iron to get warm. And you put a big blob of solder on there till it's got a nice voluptuous belly sticking out. And then I'm going to just show you, you flick it. You flick it off. Helps get off all of the sort of chemicals that have accumulated on your tip. Do it more than once if you like. I've already been soldering, so it's not really that necessary. Now, to make our joint, to solder our joint, we apply the side of the iron to the joint, to the connection that we want to make. And then we dab a little bit of solder on. Voila. Now, what we don't want to do is we don't want to apply heat with the tip of the iron, because it's not as effective for distributing heat. The side of the iron has more surface area, and so it distributes the heat more evenly. It also, usually the tip has some crud, some of this black stuff sort of accumulated on the top, so it's harder for molten solder to get to that point. Another thing that we definitely do not want to do is to put solder on the tip and then just kind of dab it on like that, like we're gluing something. That doesn't work with electronics. The reason why is that your solder is just going to sit on the top here. To focus this. There we go. Your solder is just going to sit on the top. Even if it looks like it's making a good connection, it's hard to tell whether or not it actually is. So again, what we do, we focus our camera, then we apply the side of the iron to the joint, and we just dab a little solder on right there. Now, if we're making a good connection, we can I like to bend the legs up in order to check this part. It makes it easier to sort of see what's going on. But you'll notice that we have this sort of Hershey's Kiss shape. This is my third video of the day, so I've said Hershey's Kiss about 1,000 times by now. But we've got this Hershey's Kiss shape. You can see it's making a nice connection. If we wiggle the wire, it's not going anywhere. You look at the top, you can see the solder went all the way through the hole, meaning that it's making nice contact with the leg going through that hole. So we've got a good solder joint. Now we take our snippy snip and just cut. I cut 2 legs at a time because I do this all the time and I'm impatient, but feel free to cut 1 at a time if you're at all unsure of your capabilities. Alright, so we've snipped the legs. This is what it should, after I focus it of course, this is what what the legs should look like underneath. Still have that Hershey's Kiss shape. Don't get too close to the board or else you can pull something out of the circuit board, potentially damage it. Okay, so we've got our 1K resistors next. Just pull off the tape and the little paper. Keeps it all together. Again, we just bend it over like that. And now you'll see 3 points marked 1K. You technically see 4, but remember this one was incorrectly marked. The 10K goes in this corner. The 1Ks go there, there, and there in the other 3 corners. So 10K is southwest, 1K is everywhere else. So again, side the body goes in doesn't really matter as long as the resistor is going across the section, the 2 holes that are marked with a line as such. I'm doing them all at the same time, but again, you can feel free to do them one at a time. Soldering multiple resistors can get slightly complicated for the following reason. When we bend the legs over on the bottom, sometimes you'll have, and this is just for example, you'll have all of these legs kind of crossing over each other. And that can be kind of a pain to solder like that. So what I like to do is I like to just bend the legs away from everything else Sometimes you gotta just organize everything so that they're not kind of crossing over other holes that could accidentally absorb some of the solder, make accidental connections. You don't want to do that. So just sort of bend the legs away from the other legs and away from other holes that could possibly accidentally be soldered. And now, just before we do this, I keep going back after focusing. Okay, focus in, focus. All right, again, we've got these 4 resistors in the 4 corners. The 3 that we're soldering are these 3. So we flip this guy over. And then we take our iron to the side of the joint. And I'm going to tin this actually. It's a little brown. Got a bunch of smoke in my face. Okay, so we put the side of the iron to the joint that we want to solder. Dab a little bit on. Give it a little solder kiss. To the side of the joint. Dab a little bit on. Okay, well, let's examine our work. I'm going to bend up these legs, get a better look at what's going on. Usually you can even just tell sort of how well the solder took the joint, took the solder by just kind of moving the leg around. And if you don't feel anything moving, then that means that you've made a good joint. Because if something's moving, that means that the solder that you put on there didn't actually connect to the solder on the board. See, all this silver is just a thin layer of solder that they apply in order to make it easier to bond to. So if you're wiggling and you can see here next to the board it's not moving at all, that's a good sign. So we're going to go ahead, use our snippy snip, take care of all of these legs. Just kind of get a good look at what's going on here. It looks good. All right. We're almost done, believe it or not. We got our silver package that we're going to open up. Okay, now this part is slightly more complicated, and that's because both of these parts need to be put in the board in a specific direction. This tape keeps getting stuck to my fingers. All right. Now you'll notice this is called an LED, by the way. You've probably heard of LEDs. They're quite neat. They make light. And you'll notice that one of the legs of the LED is shorter than the other one. That indicates the direction that it goes in the board. If you look at the board, you'll see a little minus sign to the left of this circle labeled LED. So if we line up the shorter leg with the minus sign, that's the way that we want to be putting this in the board. So again, short leg goes to the left where the minus sign is. If you do this incorrectly, your module will not work. I can guarantee it. So be extra careful to check twice before soldering. As they say, measure twice, cut once. If you're at all unsure about which way it should be going, you can either watch the video again or you can contact me. My email will be in the description. I just love answering emails. It's what I do. So we're bending the legs kind of away from each other just to keep it in place. Another way that you can actually check after the LED has been soldered in is that there's these sort of metal wedges on the inside of the LED. The large wedge is the side that should go to the minus sign to the left. So the it's kind of hard to see in the camera, but in person you should be able to see that there's these kind of triangular pieces of metal inside of the plastic. The larger one is the one that we want to go to the minus sign. Just in case you want to double check if you're having problems with your build and you're going, wait, maybe I put this in backwards. That's how you can check. So we'll go ahead and do the same solder process we did before. Side of the iron, dab on the solder. Check the joints. Be careful because the wires can still be hot while the solder is cooling. You want to be careful just to not just be aware of the temperature of the metallic object you're about to touch. So yeah, these joints look good. Go ahead and snap them. You'll notice I'm a little less energetic than in the other videos. That's because I waited for night because I thought it would be cooler. Joke's on me, it's just as hot in here. So we got our LED in. Now we can solder in the Vactrol, the thing that does all the magic. Now, if we just take a quick look at our Vactrol, we'll notice that one side has short legs and the other side has long legs. Now, the thing to know is that the short legs go to this little triangular area on the left where the holes are very close together, and the long legs go to the right where the holes are very far apart. And there's actually something beyond that, which is that this dot right here, that's also important to line up. The dot goes towards this sort of angled area right here. Inside the Vactrol is an LED, and this dot marks the cathode, that negative point. So the triangle points to this angled section, which is where the dot goes. So again, dot in the lower left-hand corner, southwest, and that should line everything else up. So you can put the long legs across. And again, if you do this wrong, your module won't work. So just double check before soldering, because after soldering, who dug it? It's a real pain in the butt to get out. These long legs don't want to cooperate. There we go. So we have our LED, rather our Vactrol. I like to take my pliers and just pull the leg through so it doesn't look funny. If I hate one thing in life, it's funny looking Vactrols, let me tell you. Alright. Just kind of bending the legs down to keep it all still while we're soldering. It's not absolutely necessary, but it helps. It helps. So again, before you solder this thing, by golly, you got to check that that dot is facing the right direction. And I'm emphasizing this so much because I know later some of you are going to contact me and be like, my module isn't working. I'm going to be like, did you check where the dot is? And you know what they're going to say? They're going to say no. Don't be that guy or gal. Tinning the iron. Now we just do the same thing we always do. Put the side of the iron against the joint and apply a little bit of solder. Side of the iron to the joint. You can see my circuit board's wiggling a little bit with the Vactrol sticking in. That's okay, just kind of try and push the iron down enough to keep it all still. There we go. Now, you might have to snip these LEDs, or rather, sorry, these legs But these ones are shorter. Actually, you know what? Okay. What I'm seeing here is that this leg might accidentally touch that pad. So I was thinking that I didn't have to cut them, but just to be on the safe side, I'm going to cut them. I kind of bend them up a little bit first to make it easier to do. And snip it. You can see there's a very small difference, but we don't want to make accidental connections. Now we fold these legs up. Chop, chop. You're mostly done. Now, up until this point, both boards, both the VCA and the LPG, have been exactly the same. I actually soldered another board up to this point just to show you the difference between building the two. I'm going to start with the low pass gate because it's the easiest. We've got our little capacitor. There's this little square down here with the completely unreadable writing. Actually, I can barely read it, but you know, it looked a lot better on the computer, let me tell you. It just, it didn't come out in the silk screen, but that's fine. The marking is this little rounded rectangle and the two holes inside. You want to put the legs through the holes inside the rectangles. They're really the only holes that are left in this entire project, so it shouldn't be too hard to figure out. But again, you can see that the capacitor mirrors that rounded rectangle. We just, a little leg came along for the ride. We just solder this. Same as usual. Probably getting sick of me saying it. Alright, bend the legs up. Looks like a good connection, so we'll just snip them off. Oop. Doing a somersault. Okay. So this is basically a complete low pass gate. You still have to solder in the jacks, but I'll show you how to do that on the VCA, just because this is the board we've been making from the beginning, and it would be terrible not to find out how its story ends. So we've got our trimmer resistor. This is the last part that you should have, besides the jacks and the other sort of mechanical stuff. But this part is what we're going to put into this hole instead of the capacitor. Now you'll notice we have 3 legs here and not 2. Unfortunately, we have a solution for that. Oh my gosh. Just snip off this last leg. Now we have 2 legs. Do you like how PG this video's been? I normally swear like a sailor, but since I know kids might be watching this, I've been very good about not swearing. So, got 2 legs here. There's going to be the 2 legs that went in where the capacitor is. Just going to put it into the rounded rectangle. Now you'll notice that this 10K is kind of getting in the way. That's alright, we just kind of rotate the resistor. And you know, it's at an angle, it's not the most beautiful thing, but I tell you what's beautiful about this setup is not having to swap out a bunch of resistors in order to figure out the right one. Trust me, you'll be glad you have this. If you are probably more experienced that you don't have to watch this video, you can do it, but having the trimmer resistor there, it makes things a lot easier. So I bent the legs out. Now we're just going to solder them like usual. Getting smoke in my face again. I really need a fan in here. The problem is that the fan shows up in the sound for the video, so instead I get smoke in the face. This is what I do for you, for my beloved DIY community, inhaling toxic solder fumes in a hot garage with no fan. So we're just going to go ahead and chop off these legs. I don't want to sound like I'm kvetching or anything. I'm just letting you know how much I love you. So there we go. We have this towering blue trimmer sticking out. And I'll show you how to calibrate this later in another cut. But yeah, this is what the VCA should look like. And just one more time for comparison, this is what the low pass gate should look like. I'm trying to use the glare to give you a better image, but yeah, so if everything looks fine so far, we're going to start with the jacks. Now the jacks have 3 legs. You'll notice there's 3 holes where these little rectangles go. So there's really only one way that you can put the jacks in, and that is with the plug facing the outside of the module, just in case you get confused somehow. I get confused, it's okay. I've got all 4 of our jacks in. Not too bad. And you're looking here, you'll notice that these pieces of metal that we're about to solder and the pads that we're going to solder them to are a little bit larger. So I like to turn my iron up just a tiny bit, not too much, because if we turn the iron up too much, we could possibly damage the board. So tin the iron again. Just make sure everything's nice and flowy. I like to go in one direction because, again, we're using the side of our iron. So I like to do one direction, all of the pins, and then I rotate the board and I do the other direction. So you'll see this big flat piece. Just stick the iron across the side, and then you add solder just like before. But a good thing to kind of gauge how well your joint worked is if the entire hole that was there before, the entire hole is filled with solder. That's usually a pretty good indication that you made a good connection. Doing the same thing. Can you tell I do a lot of this? I had to get a day job where I solder all the time too. So I solder for this, and then I solder for my day job, making props, and I do a lot of soldering. But soldering's fun. There are much more tedious things that I could do for a job. Like, I don't know. I guess it's better than cleaning a bathroom or something. Again, we're just taking the side of the iron, and then we apply solder to the pad. You don't even really need to touch the iron. Hopefully, if you're doing things right, the iron will heat up the pad enough that just touching solder anywhere on it will cause it to melt. Now if we check our solder job, some of these are still hot. So again, be careful. Yeah, so it's kind of like before, except instead of a Hershey's Kiss, you just sort of see a mound of solder, an elongated kind of bent up area. Earlier I called it a Hershey's tongue. Just coming up with all my own names for this stuff. But yeah, you can see that all of the holes are filled up. There's a little tiny hole there, but that shouldn't be an issue. As long as you can see solder connecting the tongue to the rest of this pad, everything should be fine. Okay, so we've got our VCA, and it's done. Now we all just have to mount it to the acrylic backing, the fun part. So these little standoffs, just take them out of the bag. You'll notice that they're different on both sides. One side is more angular, the other side is more round. Angular, round. So we're going to put the round side through the circuit board for all 4 legs. Oh, let's do the wrong side. If you do the wrong side, don't worry, you can pull it out and redo it. It'll be fine. Now we take the acrylic backing and we line it up on top of all 4 posts before we start. Now, instead of trying to put all of your force on one corner, you can snap this acrylic backing. I mean, it's pretty strong, but like full human force strong, you need to distribute it a little bit. So what we do is we just take 2 sides at the same time, snap it in. Makes a real satisfying sound. And pull on it, nothing's going anywhere. There you have it. That's a Vactrol VCA. If you built the low pass gate, then you have a low pass gate and you're done. If you built the VCA, I'll meet you in the next video to show you how to do the calibration procedure. It's pretty easy, but you know, it's worth doing and taking the time to do it right. Okay, so here we are on our last leg of the trip. You have your 0HP Vactrol VCA all built up, and you want to know how to trim the VCA for the desirable decay and bleed characteristics and how to balance between the two. So now what you are going to need is a relatively small flathead screwdriver, such as the one that my camera is having difficulty focusing on. Anyways, you can see it from this far away. Flathead screwdriver. It's really the only thing that's going to fit in a small slot like this. I have a audio signal coming in from the spectrometer, just a square wave oscillator, and then I have a channel of function sending a really short trigger. Short triggers are nice to be able to hear the actual decay characteristic of your envelope. So as I'm going to turn the speaker up, we're just going through the camera speaker, but it should still be good enough for you to hear. So you hear how we get a loud pulse and then a long decay that borders on bleeding afterwards. So what we want to do is we want to take our trimmer and just turn it down until that bleed goes away. You hear how right around here the bleed starts to get quieter? That's what we're looking for, is to kind of straddle that edge where the bleed goes away. Now, it's never going to go away completely on some Vactrols. They just have a longer decay portion. It's really hard to do this while looking at the camera. See, right around there starts to get much quieter. You can hear it's still there, but it gets a lot quieter. So now the bleed's gone away completely, but if you listen, the entire thing is much quieter. So you're just going to have to turn that trimmer to a point where you feel like you can deal with either the amount of signal loss or the amount of bleed. And I would say that this is probably around where I would put it. That bleed is slightly higher than I would like it to be, but if you'll notice, the weird thing about Vactrols is that once you turn them on, they sort of stay on for maybe like half a minute, and then they decay over time. So it can be a little tough to calibrate these. In general, this is around where I'd like it to be. Vactrols aren't perfect, so you always have to balance between signal loss and signal bleed. So if we put in a faster, maybe longer envelope, there's still a nice long decay, but it's much louder during the active portion of the envelope. Yeah, I'd say that's good. Anyways, there you have it. You now have a functioning Vactrol VCA. If you liked this video, go ahead and let me know in the comment section below. If you feel like I could be doing something better, let me know that too. And yeah, thank you for watching. I hope you enjoy the heck out of your Vactrol VCA and or low pass gate.